So show of hands, who here makes money from somehow inside the 3D industry? They got a job at a studio? Yeah, almost everyone. Who doesn't? Okay, what are you guys doing here? No, I'm kidding. So I love this job. It's fun. And that childlike wonder of like, yeah, bringing something from my head into life is still there. I really enjoy it. But I want to continue doing this, you know, because it's a fun job. But if you've paid any attention to the news, then you've no doubt seen reports of automation and AI, the doomsday theories that we're all going to be out of jobs, all sitting on the street, nothing to do. And I always thought like, yeah, but that doesn't apply to 3D, because like what we're doing is art and computers could never replicate art. But then you see a couple of stories like how machine learning was used to create high fidelity animations on the face of Thanos. I'm like, okay, yeah, all right. And then you see an algorithm that'll take the styles from famous paintings in history and apply it to a photo. And then I'm really sitting up and paying attention because I'm like, okay, I didn't think a computer could do that. And so I wondered, like, what are we looking at here? Like, it kind of made me wonder if this is, you know, the old days of the Disney 2D animators being replaced by the 3D animators. Are we going to be replaced by server racks running AI and machine learning to auto-generate the movies? So that is what I'm going to discuss in this presentation, how AI and automation might change the 3D industry. Quick side note, I'm going to be using terms like AI and machine learning. And some people are like, no, that's not AI, you've got to call it this. And for all intents and purposes, it doesn't really matter for what I'm talking about. At the end, it's still the same result, right? It's a software doing something that an artist does. So anyways, there is one guy who's very good at making predictions for the future. The Amazon guy, Jeff Bezos, who's in hot water at the moment for his treatment of staff. Wasn't very good at predicting that. But for the last 20 years, he has been basically ahead of the industry. And so he said, I frequently get asked, what's going to change in the next 10 years? I almost never get asked, what's not going to change in the next 10 years? And that's actually the more important of the two. And he went on to explain that, an Amazon customer of the future is never going to say, I wish the prices were higher, or I love Amazon, but I wish it took longer for my packages to get here. Right? So those two variables he knows for sure are going to be desirable in the future. So actually what's not going to change is what you should be focusing on, not worrying about hypotheticals. And so I thought that's great. It's a great exercise. And applying that to 3D, I think that any technology that makes things better, faster, or cheaper will eventually become standard. It's inevitable. Things get rolled out. Once the studio execs realize that this is going to save them money, they put it into practice. So what is costing money at the moment? Games are costing money. So Raf Costa plotted some games from 1985 to today, and he found a disturbing trend that every 10 years, the cost of games go up 10 times. So this is a log scale. It looks deceiving, like it's not that big of an increase, but every single one of those horizontal lines there represents a 10x increment on the one before it. So basically every year, it goes up 25%. By 2020, the average AAA game might cost $200 million. So they're already more expensive than feature films, and it's getting unwieldy because they all have to spend more to try to outcompete the others. And mobile gaming, yeah, it started out cheap, but that's happening as well because it's now a saturated space. So the costs are way too high, and they need to come down. A big portion of this cost is assets. Assets are unreasonably expensive. So let's say, for example, you're making a video game that involves a street. You've got to have characters running down a street for whatever reason. So you've got to model a building, okay? And it's a pretty detailed apartment, so you work pretty hard. You might be able to get it done in 12 hours, okay? Then you've got to texture it. Texturing often takes just as long as the modeling, but let's say you get it done in 10. And then halfway through the work week, you've got it done in 22 hours. Which, by the way, is unreasonable because that assumes you're productive 100% of the time. It's usually more like 50% of the time. But let's say you got it 100% productive. Then if you're in the studio, there's also a revision multiple of 2 to 4 times. Narrative changes. Maybe they want to make it take place in Paris instead of New York. Maybe they want to have a tunnel running through the building for whatever reason. So changes have to happen repeatedly, and they have to go back and revisit old assets. So at a cost of $60 per hour, the average wage, this building ends up being about $3,900. So when you look at a game like The Division, put price tags on everything, and it's very easy to see why games are costing hundreds of millions of dollars. This is kind of dumb, right? Because like we're working virtually. None of this stuff exists in the real world. Like we should be able to approach this smarterly. Because I think that a large portion of this cost comes to the fact that this is a static workflow. You're getting a one-for-one input to output ratio. If you want to make another building, you often have to repeat the work. And sure, you might be able to, start from the base of the other, but you often have to do so many details and topology change, and then you've got to retexture it, so you're still getting a pretty similar output. So I think that the first leap that's going to happen to the 3D industry in the next 5 to 10 years is procedural workflows becoming mainstream, or the standard, to say. So approaching the problem of modeling a building, to do it procedurally would look like this. Instead of modeling the building yourself, you would set the parameters for what a building should look like within certain ranges. So a building should be this height to this height. It might have between 5 to 10 windows on it, 2 to 3 doors. It could have this many floors in range. And then basically you let the software self-generate. And this is how you bring those costs down. So this was actually a course taught by Anastasia Opera, who I believe is actually Dutch, could be wrong, but she made a procedural lake village using Houdini. And she went on to explain that she thought that proceduralism would really remove the creative aspect of it, but actually it forced her to understand like what makes something look good, because you often don't know as an artist. You just like doing things without thinking about it. But when you had to put it into a program, you had to explicitly define what that looks like. And so that was a good exercise. And then also what you got out of the machine at the other end was often ideas that you hadn't thought of before. So it can actually be a huge advantage. So this is procedural modeling. Obviously, you've got to then texture it. In this example, it's textured. I'm not sure how she did it, but texturing. So I run Polygon. Who here's heard of Polygon? All right, my advertising worked. So when we started Polygon 2 years ago, every single texture on the website was captured with a camera. And we would find a floor like that, and then we'd say, great, we need another floor. We would have to find another wooden floor, capture it, make it seamless, process it. So it was that one-to-one input to output. Then we discovered Substance Designer, whereby you would spend a lot longer generating a node setup, making something 100% procedural, meaning that no camera was involved whatsoever. You would make it digitally. But once you've made it once, it's very easy to create variations from that. And so immediately we realized the benefit of this. Not only could we capture things that are very difficult to capture, like marble, wood, otherwise you've got to go into people's homes and capture their floors, but also it was a huge cost saving. So basically, that's all we do now. A lot of our materials are now made with Substance Designer, save for photo scanning, which is still best captured for grounds. But yeah, we've doubled the size of our team, and game studios have realized this as well, which is why you look at job listings, they're all hiring Substance Designer artists. Then, of course, you've got to apply this to a model, okay? Model will have creases and crevices and all sorts of occlusions that you've got to take into account for. So Algorithmic was very good by making a sister software, Substance Painter, which enables you to take the thing, it'll bake all the maps for you, and then it'll apply the smart materials that you got from Substance Designer, smart masks and things to add in grunge and whatnot. So it's the #1 texturing software in the world right now. For this very reason, it is saving studios hundreds of thousands of dollars because it's procedural. When you go back and you change something with the model, if you've got the pipeline right, it should auto-update with the texture. So very, very cool. And then finally, you've got level design, so putting the assets into it. So I had at the start a New York City example, but let's say you're making a forest, okay? So Far Cry 5, they've made a lot of Far Cries, 5 of them in fact. But Previously, they went about, like you would make a forest usually. Like you'd have particle systems and you place things by hand. But the problem was that as the story would change over the months, the landscapes would move around as they had to have roads go through different places. And every time they did that, they had to update and hand place and remove all of the trees. This time they did it a different way. They created an ecosystem. So they set rules to define where certain trees and plants would live. So big trees would grow towards the center of the forests, small trees towards the edges. Underneath the trees, there would be ecosystems of smaller plants that would grow in the shadows. If it was near a lake, there was going to be different plants there. It would automatically update according to the altitude. So if it's higher up, there would be smaller trees. And then they were able to build in handy tools into that as well to quickly build roads and buildings. And the whole talk is definitely worth watching, by the way, if you get a chance. So this, I think, is going to be the future, this workflow. Procedural modeling, materials, texturing, and world building. Already, materials and texturing are pretty well embedded into the industry now. It's pretty well standard. But I think modeling and world building are going to be taking the next spot. At the moment, Houdini seems to be really good at this, but I'm really hoping that Jux, wherever he is, yeah, there he is, hassle him about everything nodes, because I really hope that this can come into Blender. So, that was leap number 1. What was that? Leap number 2, machine creep. Okay, so this is where it starts getting interesting. So traditional software typically works like this. You have an input. Let's say you've got a photograph and you bring it into Photoshop. And then you want to apply a filter to it. You apply the action to the photo, and then you get one output. It's very predictable. You know what you're going to get. And also leads to, obviously, a lot of manual work, tweaking things as you need. Machine learning is different. You start with an input. It might assess it. It might apply an appropriate action. And then most importantly, compare it with others from its training data set, then be able to judge whether or not it is good or bad. Sometimes a human has to do that step. If it's not, try again. And this, by the way, is a very gross oversimplification of machine learning. I'm not a computer scientist. I didn't go to university. But this is what's helped me as an artist to understand this process. And basically, the result that you get out of it is usually multitudes better than traditional software. So the key point here is that it has the ability to learn and to improve over time. Now, what it needs in order for that to happen is huge data sets and fast hardware. So I think 5 years ago, you started, hearing the train of news about machine learning taking all our jobs, and everyone was hyped up and scared, and then nothing really happened. And I think a large part of that is because there's not enough data and also not fast enough hardware. I think now we're reaching the tipping point. And actually, you're starting to see some consumer software that is making use of machine learning already, which I'll show you in a second. So one thing machine learning is very good at, denoising. Okay, so everybody's familiar with noise. You render something that's grainy, right? And denoisers typically will smooth it out. A machine learning denoiser will do it really, really well. So this is one which is owned by NVIDIA. I assume it's the same one that is used for the RTXs, which is enabling them to do real-time ray tracing. That is, by the way, how their RTX is able to do that. It is rendering one sample every single frame of the game, and then it is applying a denoiser on the same frame. So it's doing this in real time. And how on earth it's able to take that blue square, that noisy blue square, and read anything from it is a testament to how machine learning is working. That's just absolutely insane that it's doing that. So Blender's Cycles denoiser, as far as I know, has nothing to do with machine learning or AI, and so it obviously would very much fail in this situation, which is why I really think Blender needs to get into machine learning and AI. Disney and Pixar also own one, and they're trying to solve the problem of the frame flicker, because that's a common problem with denoisers, but they're also building artist tools to do it. NVIDIA own most of the papers regarding it, and I think that's because they realize there's a huge amount of money in it, because not only every renderer will need to use their denoiser, but also every camera manufacturer, because if you've got low light sensitivity and there's all this grain, well, they can solve it with denoisers. So that's one thing it's good at. Another thing is up-resing. So you've got a small image, small little JPEG you find, and you're like, but I need it to be double that size. This is up-resing. So as a test, I took this image, which I'm making at the moment, of a kitchen. I rendered it at 50%, and then using AI Gigapixel from Topaz Labs, I up-resed it by 200% so that it is now as if it was rendered at 100%. And then I compared it to an actual render at 100%. And if you look at it, there's not a lot of difference there. And obviously there's a little bit more detail in the one that was actually rendered 100%, but not much, and certainly not enough to qualify like a 4 times extra rendering. So this was like really caught my eye. I was like, wow. And this is consumer level. You can actually buy this. You can get the trial, or it's $99 or something like that to purchase the full thing. This is already out there, and this is a start, I think, of where the industry is going. And there's also other uses, like, for example, motion capture. So I think we're going to be doing away very soon with the mocap suits and the expensive studios, because now you can capture just from raw video. So there's no sensors. This is not a special camera. This is just simple video. And the algorithm, whatever it is, I don't know what I'm talking about, was able to figure out where the bodies are. And most impressively, it's able to guess the occluded parts, like what's on the other side of that arm, because it can't see that, but it's guessing. And it's doing an amazing job at it. So I think it's in the future, they're not going to have mocap suits. They'll just film the actors doing whatever, and that's going to be it. And then there's this other one, which, to be honest, I don't know how it works, but they filmed a dog in a mocap suit for an hour, doing running and jumping, and then using neural networks, whatever that is, they translated that into player motion in a game. And what's most impressive is its transition from one behavior to the next, going from running to walking to jumping, is incredibly seamless. There's also very little foot sliding, and there's also another example with a human, and it adapts to the terrain and it jumps over things. I think this is inevitable. I think you're going to start seeing it in games. So that's machine learning. Basically, we're just going to start seeing it in our software in the future. You'll start, you'll have an action in Photoshop and you'll be like, oh, that looks really good. You find out it was machine learning built into Photoshop. Premiere, probably most Autodesk products. I think Blender needs to really get into it. I think it's the future, and I think every Silicon Valley company has realized it, and yeah. There's this quote by the guys who made the Thanos facial animation. If you're not using machine learning in your software, you're doing it wrong, and I think that's very true. So leap number 3 is machine-assisted creativity. So this is really fun, because this is something that I always thought that computers would never be able to do, like creativity. Like, that's something that is very human. And it's true, like, intent is very hard for a computer to do. But you would be surprised at what it can actually do to help you, okay? So as an example, as I mentioned, I'm working on this kitchen scene, which I wished I could have got the tutorial out before I came to Amsterdam, but I ran out of time, so it's going to take another month. But I'm working on this scene, and whenever I'm making something, I reach a certain stage, like this, where it's okay, but I know it could be better if I tried more ideas. So you just start throwing stuff at the scene and seeing if it looks better than what it did previously. So you might change the lighting, add in some little blinds, and might be a marble on the left, and then you try it with adding food to the table, no food, adding some boxes, no boxes, a refrigerator instead, and you just have to keep doing this. And what I've realized that as my workflow, this really eats up about 50 to 70% of the production time. And there's a bunch that I haven't shown you, like 20 other renders, where you've got to try this stuff, and it takes so much time. Sometimes you have to model the thing. Like, was it going to look good with a wine bottle? I have to model a wine bottle, or you purchase it, or whatever. And then you place it, and then you have to render it, and that is a really, really long process. So if there was software that could do this for you without you having to go through all the effort to add it in there in order for you to make the decision if this is good or not, that would be incredibly powerful, right? So there is, hey. So this is a really impressive paper. You give it an outline of an object, the photo that the outline was based on, and then it will generate a bunch of ideas for you. And it works really, really, really well. So it actually helps to see it as it's generating. So this is a building facade. The only thing that was given was the top row, and then this is the shoes. And if you paused it at any point in this, any one of these frames here could be a unique design. So I think that this is kind of the future. I think what we're going to see is you'll make a character, for example, and then you'll put it into the software and you'll try out a bunch of ideas, different clothing, different types. This is one used for an environment, different sceneries. What's crazy is that the input that's given to it is so simple, and yet it's just churning through ideas and spitting it out. And I think that this is absolutely going to be part of a lot of creative meetings in the future. This is actually one you can try online if you go to that web address there. It's based off a different paper technology, but very similar thing. So I drew this cat, right? Very simple looking cat, and then I hit a button. It reminds me of those things where it's like, you know, like the dad finishes the children's drawings, and he's like a really good artist, and he just makes it look high fidelity. Obviously, it doesn't look very good, but that's because my drawing is crap. But you could obviously see, like, it's not going to be a finished product, but this would definitely be a starting off point for a lot of concept artists. So I think it's a sign of the times. We're going to start seeing this. Speaking of which, does anyone recognize these celebrities? Does anyone know who they are? Anyone want to throw a name at me? Any name you think it is? They look familiar, right? You're like, is that like a footballer? Pretty sure I've seen her in something. Either she's a musician or an actor. Well, actually, they're imaginary. They don't exist. They were generated. This is a separate paper whereby you feed it a bunch of images and then it spits out a result. Really, really impressive. So obviously, realistic examples, you could get by, you know, if you've got like a game and you need to have 20 different NPCs, and I don't know, you just pull photos of people that match the region that you're creating the game for. Like, oh, I need 20 NPC Mongolians. You just download a data set of Mongolian faces, and then you just got unique faces. There's no like likeness infringement or whatever. You've just got uniqueness. But it also worked for other things. I don't know how it did this because these photos have perspective in them. But this was also generated, these bedrooms there, which is bananas. That's exactly what I need for my kitchen, right? If you could just put it in and then generate a bunch of things. So I think that's what's going to happen. You're just going to have your mood board of all your ideas for your environments, and it's just going to generate ideas. Or, and this is where it gets really freaky, real spooky for Halloween. What if you didn't even have to provide it with images? What if you just typed out your idea? Like, this bird is red and brown in color with stubby beak. What? That's real. It's not pulling from a stock library, by the way. That was generated. So, amazingly, the way this works is that it was trained to recognize what the features are and what something is, like red bird. Okay, this is what a red bird looks like. Then when you type that out, it creates the blob of whatever that shape should look like, and then there's a second pass where it adds in the detail to that. And it's crazy. Like, this is like the closest thing to like sorcery. I don't understand it. In fact, like a lot of papers I've seen, I'm like very skeptical. I'm like, they're cheating. There's something they're not saying because this can't be true. But if it's as good as this is, and it's like today, I think this was actually from 2016. I think this is inevitable. You're going to have a creative meeting with a director who's like, all right, let's create some ideas. Ancient city, a road through the middle, canyon in the background. Spit out like 20 different ideas. And then one of those ideas you give to your one concept artist to flesh it out. I don't know. I think it's inevitable, right? And then another really interesting one is style transfer. Has anyone seen these, by the way? Style transfer. Basically, you feed it a bunch of images that you like I want this style from Claude Monet, whatever. And then you put an input in. This is my photo I took on my holiday, and then it spits it out, which is just crazy. And it also works for video, which is really cool as well. If you look at the paper, they filmed like in, I don't know, somewhere in Germany, people walking down the street, and it's a painting, but every frame is moving, and it's so weird. And what's most crazy of all is that it actually fooled 39% of art historians into thinking that they were looking at something that was actually painted, not computer generated. And I couldn't think of anyone more wanting the machine to fail than an art historian. But it worked, right? It worked. So my prediction is that artists will use machine learning to explore new ideas. I think that's just going to be the future. It's just going to be part of our pipeline. It'll first of all start going to studios, and it's going to be in the hands of consumers, and we're all just going to go like, yeah, how I made this scene. First of all, I generated a bunch of ideas. I think that's how it's going to work. So these are the expected changes that I predict will happen within the next 5 years. I think procedural workflows will become standard. I mean, texturing is definitely already there with Substance Designer and Substance Painter. But I think it's going to happen with level design as well as modeling. Machine learning is just going to slowly creep its way into all the software that we use, and it's going to do a lot of really tedious technical things. And then I think we're going to get creative assistance from machines as well. So I can feel the mood in the room. It's a little like, oh no, what is this? Are we being replaced? So people had this thought actually in 1997. When Kasparov was beaten by the IBM Deep Machine. That's what it was called. And it was the first time that a computer had ever beaten a human. And people thought, like, that's it for chess, and it might be the end of humanity, too. It was depressing. And they thought, like, chess is dead. And then Kasparov realized that, like, you know, if the computer has access to all, you know, potential moves of all the previous of hundreds of thousands of games, and it's able to work from that, it should be fair if the human also has access to that. So he created something called advanced chess, whereby the human player has access to the same information the computer has, and he will listen to the computer and occasionally override it, just like you would a GPS navigation when you know something is wrong based on what the computer is giving you. And today, the best player is a human-to-machine counterpart. A purely AI chess will win in a tournament. It won 42 games, whereas a human and machine won 52. So there is a purpose to your life. It's not just all machines. And what's more so is that since then, the number of grandmasters in the world has doubled. So it wasn't the end of chess, it was good for chess. So I think it's the exact same thing is going to apply to our industry. I don't think that these new technologies, I don't think it's not going to make artists redundant. Because, you know, you give this to a monkey, he's not going to be able to make anything good out of it. It's going to be hit a few buttons, and yeah, it might generate some semblance of an image, but it still needs the human to put intent into it. So I feel like based on these learnings, the most at-risk jobs are those that are labor-intensive, narrow-skilled, and repetitive. The great jobs like mocap cleanup, rotoscoping, retopo, mesh cleanup make 100s of these jobs. Basically, the kind of thing which is usually outsourced to a floor of workers in India where they've been told to rotoscope these shots from the upcoming Hollywood film, where you just try to just throw manual labor at it. I think that's something which will definitely be replaced. The safe jobs are those that involve critical thinking, wide-skilled tasks where you know how to use different softwares and different solutions in the right way, and niche tasks which are too small to bother automating. So art direction, project management, good generalists, programmers obviously to oversee a lot of the scripts and the programs people are using, and freelancers because there will always be a market for people who don't want to use any software whatsoever and they want to pay you instead. So really the at-risk jobs are the undesirable grunt tasks. It's the stuff that nobody wants to do, but we have to because it's part of the job. The actual art, I think that's safe. And failing that, if that itself, you know, wasn't enough to make you feel better, the forecasts for the 3D industry is insane. It is blowing up. For almost every single one of these sectors, you're expecting to see huge amounts of growth over the next 5 to 10 years. And that's not, by the way, even taking into account VR. One report said that 3D rendering and visualization is expecting to see 25.5% growth per year until 2025, compound annual growth. Or basically double by 2022 and quadruple by 2025. So the number of people at this conference in 4 years from now could be double that, and by 2025 quadruple that. I think the 3D industry is poised to blow up. So yeah, maybe each studio there would be a reduction of the grunt work, the juniors that they're hiring to do the stuff that nobody actually enjoys anyway. But in its place there might be 5 studios around it. So that is it. That was anticlimactic, wasn't it? guys. Thanks, guys.